Hello everyone, welcome to the another very important session in which we will be discussing some more important questions and very important concepts of mathematical physics. So I hope this session today will be helping you a lot to prepare many important concepts of mathematical physics in very less time. And in case anywhere if you will find that something is not going to get clear to you, you can surely tell me about it in the comment section. We will try to consider many points, many concepts in the session today. So get ready to know about all these important concepts which are very much expected in your upcoming exams. And I hope that today's session will be helping you to be more confident about your mathematical physics preparation for the upcoming exam. So we are now going to start the discussion about all these important concepts. But before that, I will just be taking some time to let you know about the important points related to the Unacademy subscription. So as you can have a look at this slide right now, which I have shown you. So in that case, like if somebody wants to attend the regular live classes of well-structured and well-planned courses by the top educators, then you can take either the Unacademy Plus or the Unacademy Iconic subscription. As you can clearly see the difference between the Plus and the Iconic subscription here on the screen as it has been shown. So if you will be taking the Plus subscription, you will be able to get all these benefits, and if you will be taking the Iconic subscription, then you will be able to take, you will be getting all these benefits. Clear? One more thing here I would like to tell you guys, that whenever you will proceed further to take the subscription, you can use and apply the referral code that's Anjali A Live as it has been mentioned here on the screen. I will also be checking out here my side whether everything your side is okay, clear or not, and then I'm just going to continue the discussion. But anytime whenever you are going to proceed further to take the subscription, you can use and apply the referral code that's Anjali A Live as it has been mentioned here, and you will be getting the 10% discount at the same time as you will be using and applying this referral code. So I hope each and everything is clear your side, guys. But in case anywhere if you will find that something is not clear to you, you can let me know about it. Clear? Also in upcoming days, many new courses by the top educators will be starting on Unacademy. So if you don't want to miss these courses and the classes and you want to join them from the starting, then you can take the subscription and start your preparation under the guidance of top educators. Very good evening, Mohit, Neeraj, it will be all right. Your side you can see in the settings. Now tell me whether this one is clear or not, because sometimes it happens just because of the color it's not clear. And if it was not clear, I'm going to write the referral code here once and we will be proceeding further. That is ANJALIALIVE. This is the referral code Anjali A Live. If anybody is going to proceed further to take the subscription, they can use and apply this referral code and you will be getting the 10% discount in the total subscription amount. Clear? So now also Neeraj, your side you can check in the settings section, okay, and the quality will be there. So you can set it to the highest quality you are gonna get your side for the video. I think then it can be clear to you. Very good evening, Shilpa. Very good evening, everyone. So I hope, guys, now everybody is ready for the further discussion and we can start the discussion then. But in case, as I have already told you, that if you will find that something is not clear to you or somewhere you are going to have any doubt, you can surely mention it then, okay? Now let me just start the further discussion and let me just tell you about the most important points and the concepts which we will be considering here and we will be talking about in this session today. Okay, guys. Let's talk about it. Give me a second to start that further discussion. Ready? If anywhere you will find that something is not clear or somewhere you are going to have any doubt, what you need to do, you just need to mention it in the comments and we will be talking about it. Okay? So before that, let's start the discussion. Okay, guys, we will be starting the discussion about the metrics topic. While as I have told you in this session, I will try to let you know about many important concepts, and here at the same time I will keep on checking your comments too. Okay, so In the matrix topic, what kind of preparation we need to do for this topic, so that whatever type of questions are expected in the exam and whatever questions can be there in the exam, we will be able to solve these questions quickly, easily and less time. Okay. Along with that, we will be confident about this topic preparation too. So just in few seconds, no, not in few seconds, exactly in few minutes, you are gonna know about all those important points related to matrix topic here in this session, and which are going to be important for NET, GATE, JEST, DFR and all other similar exams. I hope you're ready. So here we are going to talk about the eigenvalues, but the first thing we need to understand is mostly we talk about the matrix. In the matrix topic, that is the square matrix, means the number of rows and the number of columns are equal here. Okay, so which means the row number and the column number, means for example, if 3 rows are here, so 3 columns will be there. If 4 rows, 4 columns. Okay, mostly we talk about the which type of matrix, that's going to be the square matrix. Clear? At the same time, if we want to find the eigenvalue of any matrix, then what we have to do? So if there is a matrix M, which is a square matrix, in that case, you will simply be writing M minus lambda I and you will equate it with 0. So whatever values of lambda you will get now, these are going to be your eigenvalues. So it is the characteristic equation or the eigenvalue equation, we consider it. Okay, where I is known as the identity matrix. Now what we mean by the identity matrix? It is a matrix whose principal diagonal elements will be 1, 1, 1 while all other elements will be 0, 0, 0, 0. If you will have the matrix I am given to you for 3 by 3 order na, okay, नीरज हिंदी में इंग्लिश के साथ साथ आई विल बी एक्सप्लेनिंग, ठीक है, मतलब आपको जहाँ पे भी क्लियर नहीं होगा या मैं एक बार इंग्लिश में एक्सप्लेन करने के बाद में आई विल समराइज इट इन हिंदी, तो मैं आपको साथ साथ बताती रहूंगी, ठीक है। और एक बार पहले इंग्लिश में डिस्कशन रहेगा बिकॉज मोस्ट ऑफ माई कोर्सेज आर इन इंग्लिश, बट साथ साथ अगर आपको कहीं पे भी नहीं कुछ समझ आ रहा है या एक बार पूरा कवर अप करने के बाद में आपको लगता है कि यू वांट मी टू एक्सप्लेन इट इन हिंदी, तो आप मुझे बोलिएगा, आई विल एक्सप्लेन एवरीथिंग इन हिंदी वंस अगेन, ठीक है। तो अभी तक का जो डिस्कशन था वो इस बारे में है कि जो हम मैट्रिक्स की बात करते हैं अभी एज पर अवर नेट गेट जेस्ट एग्जाम्स, ठीक है, तो उसमें हम मोस्टली आइगन वैल्यूज फाइंड करने के लिए स्क्वायर मैट्रिक्स की बात करते हैं। स्क्वायर मैट्रिक्स क्या होती है? जिसमें रोज और कॉलम्स इक्वल नंबर के होते हैं, मतलब 3 रो हैं तो 3 ही कॉलम है, 4 रो हैं तो 4 ही कॉलम है, ऐसे। तो स्क्वायर मैट्रिक्स की बात करते हैं, ठीक है। नाउ उसके लिए अगर हमें उस किसी भी स्क्वायर मैट्रिक्स के लिए आइगन वैल्यूज फाइंड करने हैं तो क्या करना होगा? हमें कैरेक्टरिस्टिक या आइगन वैल्यू इक्वेशन यूज करनी होती है, ठीक है। एंड दिस इज द इक्वेशन वी आर गोइंग टू हैव, दैट इज डिटर्मिनेंट ऑफ m माइनस लैम्डा इज इक्वल टू 0। यहाँ पे लैम्डा किसको रिप्रेजेंट कर रहा है? आइगन वैल्यूज को। अब वो कैसे फाइंड करते हैं आगे हम उसके बारे में बात करेंगे। अदरवाइज m आपको पता है, i आपको पता है, आइडेंटिटी मैट्रिक्स, m गिवन स्क्वायर मैट्रिक्स, तो लैम्डा ही अननोन है। डिटर्मिनेंट फाइंड करते हुए जब 0 से इक्वेट करेंगे लैम्डा की वैल्यूज आ जाएंगी, दैट्स इट। दिस इज अबाउट द आइगन वैल्यू एंड हाउ टू राइट द आइडेंटिटी मैट्रिक्स, दैट्स व्हाट आई हैव कंसीडर्ड हियर। इट इज अ मैट्रिक्स whose principal diagonal elements are, this is the principal diagonal, exactly this diagonal, okay, it should be clear to everyone because sometimes we can get confused that whether this is the principal diagonal or this one. So this one actually, which I have considered as 1 1 1 1, okay. So in this case what will happen? In this case this identity matrix, okay, how you will take it I have explained it here right now. You will just be putting it here at this place. Now after talking about the eigenvalues, there are few more concepts related to the eigenvalues everybody needs to know. So by using the characteristic or the eigenvalue equation, you can easily find the eigenvalues. The second thing is that once we got the eigenvalues, we should understand the concept of trace. What is the trace exactly? The sum of principal diagonal elements is known as trace. So for example, this is the general kind of matrix I have written. The sum of its principal diagonal elements means the diagonal which you can see right now here, okay, which is starting from the first element. So trace is what? Trace is the sum of principal diagonal elements here. Clear? At the same time, the eigenvalues of any matrix are also related to the trace. How? So trace is also equal to the sum of eigenvalues, means lambda 1 plus lambda 2 plus lambda 3, okay, the sum of eigenvalues will be equal to what? Trace. Is that clear to everyone? Clear? Now, so trace is related to the principal diagonal elements as well as eigenvalues. Also, the maximum number of non-degenerate eigenvalues one particular type of matrix can have will be equal to its order, means either the number of rows or the number of columns. Okay, because order doesn't mean that you have to multiply the row and column. No, this simply we are talking about the square matrix. So number of rows and columns will be equal there. So either number of rows or number of columns, okay, equal to any one of these. Now trace you got by relating it with the principal diagonal elements, and as well as you got it the sum of eigenvalues. At the same time, determinant of a matrix, everybody knows about it. What is the determinant of the matrix? The determinant of the matrix is equal to the product of eigenvalues. I am taking an example. If there are 3 eigenvalues of any matrix, so product of those eigenvalues will be equal to what? Determinant. Clear? Now, let's talk about the next thing here. So, if I'm going to talk about the next one, that's going to be the Cayley-Hamilton theorem. Now, what is this Cayley-Hamilton theorem? Mohit, we will be talking about the different points too once we will cover up this section, or in sequence, whatever topics will be there, we will talk about them. Okay. Now, if we are going to talk about the next thing here, that's going to be the Cayley-Hamilton theorem. Done? So, what is that theorem? That is simply any square matrix. Okay, for example, this is M. M is the square matrix we are going to have. So, any square matrix will satisfy its own characteristic equation. And that's what? That is gonna be the Cayley-Hamilton theorem statement. Means, if I'm going to simplify this characteristic equation or the eigenvalue equation, and I'm getting one equation like this. For example, if M is a 3 by 3 order matrix, so it will be lambda cube minus 2 lambda minus 3 is equal to 0. Okay, for example, this is what we are going to have. So it's going to be m cube minus 2m minus 3i is equal to 0. That's what we will have. Clear? So what I have done, I have got this equation from here, that is m minus lambda is equal to 0. In that case, we can quickly and easily consider it this way, that is every square matrix satisfies its own characteristic equation. So that's how we will be considering it. Clear? I have just put the m at place of lambda everywhere. Now let me know in case if you are going to have any doubt anywhere. If it's clear, then that's great, but if it is not, you can let me know about it. Done? So here you got to know about the Cayley-Hamilton theorem too. Another thing is, we need to know about the eigenvectors related to the eigenvalue. Done? So how to find the eigenvector? That's the next point you need to prepare and you need to know about. If I'm going to talk about this characteristic equation by making little bit change in that equation, that is m minus lambda I into x is equal to what? 0. Done? So x is what? You can see earlier I have just noted down this much. I didn't consider x there. Done? So in this case, what is x? X will be a column matrix. X will be a column matrix. Why? Because it's a eigenvector. An eigenvector's associated matrix will always be what? A column matrix. So if I have to represent it, and let's say my M matrix is a 3 by 3 order matrix, so how I will be showing it? I will show it this way. That's going to be x1, x2 and x3. This is how I can write it. Okay, because it was 3 by 3 order. Oh, what is this now? Just a second, guys. Now it's clear. So it's gonna be x1, x2 and x3. Clear? Now, so it will always be a column matrix. One more thing about the column matrix or the eigenvector you need to know. What is that? That's simply the column matrix, whatever eigenvector you are getting, okay, that will be normalized to itself. Means if it is the matrix x, so x transpose x should be equal to what? 1. Okay, you can take it 1 or I, like depending on what kind of expressions you are getting there. At the same time, let's say there are different eigenvalues you are having, and corresponding to that you are getting x1, x2 as the eigenvectors. So they will be orthogonal to each other, means their product will be equal to 0. This is equal to 1 and this is equal to 0. That's how you will be able to get it. Please let me know in case if there is any doubt anybody is going to have. If everything is all right and clear, that's great. But if like there is any doubt, you can just mention it. I'll be talking about that too. Mention it if there is any doubt anybody is going to have. And if no doubt, then you need to know about these points and they will be making everything clear to you. And that's how, based on the different points related to metrics, you can expect and you can get the questions in the exam. While there are few more, even the tricks are there based on which we got the questions again and again in the previous years. So I will be including these tricks and the points here too. So next one is, for example, there is a matrix M and its eigenvalues are lambda 1, lambda 2 and lambda 3. By making some kind of changes in the matrix M, I am going to form the matrix M square. So its eigenvalues will also get changed in the same way as our matrix M square we have got. So M eigenvalues are lambda 1, lambda 2, lambda 3. M square eigenvalues are lambda 1 square, lambda 2 square and lambda 3 square. Done? Now, if we will talk about the matrix M inverse, clear? So its eigenvalues will be equal to what? Lambda 1 inverse, lambda 2 inverse, lambda 3 inverse. Clear? That's how we will be getting them. So what we are doing here, we were familiar with the eigenvalues of the actual matrix M. Now we have made some changes in the matrix M, means with this matrix only I have constructed the new matrix M square by multiplying M with M itself, and I have got this M square matrix. So eigenvalues of the actual matrix are getting changed in the same way as the previous matrix. At the same time, M inverse is there. So we will have to consider its eigenvalues in the same way, like lambda 1 inverse, lambda 2 inverse and lambda 3 inverse. Tell me in case if you're gonna have any doubt, we will be trying to consider that too. Okay, and it is applicable for different forms and different points. Okay, so one, please let me know which point you want me to explain again. I'll be considering that. So you can mention whichever point is not clear to you, either this one or this one or this one or previous one, like just mention the point, whatever is not clear, I'll be repeating it. Clear? So let me know guys, is it all right and clear to everyone now? Next is our important trick. So let's talk about that too. And if in case there is any doubt anybody is having and anything you want me to explain again, just mention that point. I will be considering that again. I'll be explaining that again, whichever point will not be clear to you or wherever you will have any doubt. Okay, let's go for the next point discussion now. For example, there is a matrix M, okay, and it is a matrix in a form, for example, 1, 2, 3, 2, 4, 6, 3, 6, 9. So in this case, if you have to observe the matrix, what you can observe from here? Is it a particular type of matrix? You will just try to see and just find it. Is there any doubt or not? So one, about the orthogonal part, we had this point. Guys, till that point of time when I'm going to explain that orthogonality condition, just observe this part, okay, and find it. Is there any particular phenomena pattern about this matrix you can observe? And is it present here in this matrix? If yes, we will talk about it. If no, I'm going to explain it just after explaining this point. So when I have talked about this thing, that any particular eigenvector of a matrix, okay, one eigenvector, same eigenvector I'm talking about, it will be what? Normalized. Means you may have seen sometimes we write the eigenvectors this way, 1 upon root 2 a 1 a 1 0 0, something like that. So why this 1 upon root 2 we used to get? Just because of this condition. Okay, even the dagger, if there will be some complex number, some iota present, so then you will also have to take the that dagger here, means the complex conjugate. So that product will be equal to 1, okay, as we do it in general. But at the same time, if we will talk about it's gonna be, once again, I can make it dagger or just transpose. So if there were two different eigenvectors, okay, corresponding to different eigenvalues, so they can be orthogonal to each other too. But same eigenvector, if I will consider, that will be normalized to itself, and the different means corresponding to two different eigenvalues of any given matrix, you can have the normal orthogonal eigenvectors. Two different eigenvalues will have the orthogonal, okay, and that's how you are going to get it. And this one was the only one eigenvector we are going to have. Please let me know, is it clear to everyone or not? If there is any doubt, you can mention it, but if it's clear, that's great. So one, did you get that now? So these are two different, and this one was about the one particular eigenvector. Is it clear? Done? If there is anything which is not clear to you, just mention it, and if it's clear, I hope everybody has observed the next point now and you got to know about it. So it's here. Have a look at this and let me know whether you are getting it or not. That's great, so one. Now let me know. Did you observe anything about this matrix, guys? What is happening here? And what actually it's gonna show? Is it a particular type of sequence it's gonna follow? Or it's a normal kind of matrix, what you can observe? If you are getting something, let me know. And if you are not getting anything, I will be telling you then. So tell me. Okay, let me just even help you to get that. Look at this. If you will multiply the first row with 2, you will get the second row. If you will multiply the first row with 3, you will get the third row. If you will multiply the first column with 2, you will get the second column. If you will multiply the first column with 3, you will get the third column. So it's going to be what? It's going to be the 2 1s are 2, 2 2s are 4, 2 3s are 6. 3 1s are 3, 3 2s are 6, 3 3s are 9. And same way 2 1s are 2, 2 2s are 4, 2 3s are 6. Okay, multiplied with 2. 3 1s are 3, 3 2s are 6, 3 3s are 9. So you got this. So you can see rows and the columns of this square matrix are the scalar multiple of a particular row and a particular column. Means if you are multiplying this column with some scalar number, you are getting second and third columns too. If you are multiplying this row with the second 2 and 3, you are getting the other two rows too. So this is a kind of matrix whose rows and columns can be considered as a scalar multiple of particular row and the particular column. The phenomena I have clearly shown here on the screen. So if there will be any such case given to you anytime, what you have to do now? Its eigenvalues can be mentioned directly for any such type of matrix. You can write the eigenvalues directly and the eigenvalues will be equal to trace, 0, 0. Means it is a 3 by 3 order matrix. So only one non-zero eigenvalue will be there. And what it will be equal to the trace. Trace everybody knows now. Trace is just simply the sum of principal diagonal elements. Okay, or even sum of eigenvalues. So here since we are finding the eigenvalues, so we are saying it's equal to trace. Trace means the sum of principal diagonal elements. We can directly write it. And the other eigenvalues will be 0, 0. So even our trace is equal to sum of eigenvalues because only one eigenvalue is there and others are 0. And that one eigenvalue is equal to trace. So again the sum of eigenvalues is equal to trace and the sum of principal diagonal elements is equal to the trace as well. I hope you are getting that, guys. But in case if you are not getting it or if there is any doubt anybody is going to have, then you can let me know about it. And if it is clear, that's great, great, great. So let me know. Is it clear to everyone now? Rank. Next, I will talk about the rank too. But let me know in case if there is any doubt. And if it's clear, that's great. If in case you will have any question, any query, any doubt, anything which is not clear to you, you can mention it. I'll be talking about that as well. Let's talk about the rank now. So what is rank? What is rank? For example, you are having a matrix and its determinant is non-zero. What is non-zero for the given matrix? Its determinant is non-zero. So when the determinant of the matrix is non-zero, it means what? It means its rank is equal to the order. And generally at this level, we are going to have the matrices. Matrices on which we work are the square matrix. So in that case, if I'm going to talk about this matrix and it's the square matrix, for example, it's a 3 by 3 order matrix. So whatever order matrix it is, and if its determinant is non-zero, its rank is equal to that order, means 3. Okay, so that's how we define it. But it can be the case that it is 0. Then what we will do? So in that case, if it's 0, then you have to just check out the square sum matrix now. What I mean by the square sum matrix? 3 by 3 order determinant is 0. Means rank cannot be equal to 3. But can be equal to 2 or 1? Yes, actually it can be equal to 2 and 1. How? For example, you will take these 4 elements and you will check their determinant. If it is non-zero, its rank is 2. If you will check out this one, like let's say any square sum matrix is this, any of these you can check. Okay, 4 elements matrix means the square sub matrix done, that is 2 by 2 order. So in that case, If their determinant or any one of the matrix determinant is non-zero, its rank will be 2. Otherwise, it's gonna be 3. If for 3 by 3 order matrix, its determinant is non-zero. I hope it's clear. So main thing about the rank is related to the determinant of the matrix and how you will be checking it out. That's what I have shown you here. Tell me in case if something is not clear to you. But if everything is clear, then that's great. And that's how you have to work on it and you will be getting your answer. If there is any doubt, you can mention it too. And let me know about it as well. Okay, so tell me, clear? This was all about the metrics we have discussed right now. In case if you want to ask any question regarding the metrics part or the discussion we have done, just mention it. Otherwise, we will go for the next point discussion. And before proceeding further, I would even like to give you one question related to the metrics part. Now have a look at this question until that point of time. If any question is there in your mind related to any point I have discussed, you can surely mention it. A 3 by 3 matrix M has a 3 by 3 matrix M has trace M has trace of M is equal to 6 and trace of M square is equal to 26. Okay, and trace of M cube is equal to 90. In that case, you need to find the eigenvalues of the matrix M. Eigenvalues of matrix M. Of M question mark. Options are, these are going to be 114 minus 107, 114 minus 107 minus 107, and next is minus 134,222 minus 134 and 222. Please let me know in case if there is any doubt anybody is going to have. Clear? Just try to solve it and mention your right answer in the comments, whatever will be right according to you. Whatever option or the answer is correct here, you can consider it. So for the rank, the concept remains same. Okay, you will have to take the square sum matrix and the overall determinant you can check out. But mostly, if you will see the questions which have been asked in the NET GATE or similar exams in the previous years, they have talked about the square matrices there instead of talking about any of the non-square matrix. Okay, so you can even check it out if in case anywhere you will find any such type of question, we will talk about it. Okay, so main thing is you will be getting the ideas about this type of question or any such type of question with the PYQs. So when you will be checking out the PYQs, you will get to know about it, that what kind of questions are expected and can be there in the exam. Very good, Subhavan. What about others, guys? Whoever is going to get the right answer or whatever answer is correct according to you, just mention it. I will consider it then. Done? Now, let's talk about it. Trace of M means sum of principal diagonal elements or the sum of eigenvalues. Options are showing us the eigenvalues of M. So, sum of this, that's how you will get the trace of M. Trace of M square means the eigenvalues of M square matrix and their square. If these are the eigenvalues of M matrix, the M square matrix eigenvalues will be 1 square, 1 square, 4 square. Is it giving you 26, 16, 17, 18? No. Will it give you 26 after taking the square and adding them? No. Will it give you 26, 16, 9 and 1, 25 and 1, say 26, correct. Will it give you? No. So right answer will be option C, which is showing you the sum of eigenvalues is equal to the trace. So for M square, you will have to take the square of the eigenvalues and that's how you will be able to get the answer. Please let me know in case if there is any doubt anybody is going to have. But if it's clear, that's great, great, great. Excuse me. Done? Done. Okay, guys. Let's consider the next point now. Okay, if in case you will find that something is not clear even right now, you can just mention it. I'll talk about that. But if everything is clear, that's great. Okay, let's talk about something related to the complex analysis part. Okay, so first thing is about the complex analysis, you can expect the question related to the analytic function. If we will talk about the analytic function, in that case, what will happen? In that case, related to analytic function, you need to know about the Cauchy-Riemann equations. Okay, if any given function, that is the complex function, satisfies the Cauchy-Riemann equations, then we will call it the analytic in nature. For example, there is a function fz, let's write that as fz, which is equal to u as a function of x and y plus iota v as a function of x and y. So in this case, delta u upon delta x is equal to delta v upon delta y, and delta u upon delta y is equal to minus delta v upon delta x. This is these two are the Cauchy-Riemann equations. If any given complex function will be satisfying these equations, we'll call it the analytic function. Okay, we will say that the function given to us is complex analytic function if it will satisfy the Cauchy-Riemann equations. Okay, so anytime if we want to check anything, we are generally going to have the two conditions associated with any point. One is known as the necessary condition, while another one is known as the sufficient condition. Sufficient means, for example, you are going to apply for a job, and there you are going to find like the eligibility criteria is that your marks should be more than 100%. Okay, at the same time, they have also mentioned the condition that even if your marks are more than 60% in any of the courses or like whatever degree you are having, okay, like that, so you are qualifying or you are eligible for it. That is the sufficient condition, okay, but not necessary. It is necessary that you have to clear the interview to get that job, okay, so that is the necessary condition. Now one is sufficient, that okay, it's sufficient if you are having this, you can go for the job interview, but your job will get finalized or you will be getting that job, the position, if you will clear or qualify the interview round. Clear? So in that case, that is the necessary part. So this condition is necessary condition, means if even any function is given to you that can have more sufficient conditions. Very good, Shilpa. But this is what? This is the necessary condition. It must get satisfied by the function's real and the imaginary parts, and that's how you will say that it is gonna be the analytic function. So it becomes very important for everyone to know about the Cauchy-Riemann equations. Okay, if in case there was any doubt, you can tell me about it, but if clear, that's great. Now one more trick I would like to tell you here to memorize them. You can see u and v are the real and the imaginary parts. U, v, x, y, positive, positive, u, v, x, y, same time. U, v, y, x, negative. U, v, y, x, x, y, instead of that I'm writing y, x, opposite sequence. So negative sign is there. I hope it's getting clear, but in case if there is any doubt, you can tell me about it. Now let's talk about the next thing here, that's gonna be the harmonic function. Now I would like to tell you one more condition regarding the analytic function, that if there is any function, just a second, if and only if and necessary and sufficient condition. If and only if it will happen, it will happen if and only if, अगर और like अगर ये condition satisfy हो तभी ही ये हो सकता है. If and only if it means that, okay, only if, अगर ये होगा तो ही ये हो सकता है. Clear? Other than that, necessary means it's necessary. It's like without this it's not possible. It's necessary. Okay, now at the same time, sufficient means okay, you qualify to go in the next round, or you are having that eligibility which is required just to enter in that criteria. Okay, you can enter in that criteria but necessary conditions should get satisfied to go in that particular reason, the post, whatever you want to consider it. Clear? So that's the meaning. Now let's talk about the next thing here, guys. So Cauchy-Riemann equations will get satisfied, then we are getting to know that the function can be analytic in nature. But at the same time, we need to consider the next thing here, that's going to be the Laplace equation. Or Laplace equation is what? We mostly use it in the EMT section, that is delta square V is equal to 0. That is known as the Laplace equation. At the same time, you need to know about, this is about the Laplace equation. So if the real and the imaginary parts of the function will satisfy the Laplace equation, means I don't need to write this. I will be writing delta square u is equal to 0, delta square v is equal to 0, and why it is so? If there will be any function which is analytic in nature, then its real and the imaginary parts will be satisfying the Laplace equation, and these are known as the harmonic function. So u is a harmonic function, v is the harmonic function if it is satisfying the Laplace equation. Please tell me in case if there is any doubt. Means if you have to solve any question based on it now, so how you will be doing that? Let's talk about it. You can simply write, but firstly the function should be analytic in nature. So in that case, delta to u upon delta x square plus delta to u upon delta y square is equal to 0. At the same time, delta to u upon, v upon delta x square plus delta to v upon delta y square is equal to 0. That's what you will have. Okay, let me know in case if there is any doubt anybody is going to have. Hello Suraj, and if it's clear, I'll be giving you some conditions, some questions based on these things. One more thing, guys, if we will talk about that how quickly and easily we can get to know about any function, whether it is analytic in nature or not. So in that case, there is also a condition you can prepare and you need to know about. And what is that? That is simply, if any function is going to have the positive integer power of z present in it, okay, z is what? X plus iota y. So directly just by observing it, you can get to know that it's analytic in nature. But at the same time, if it will have negative power, fractional power, just extra real part of z, imaginary part of z, any such thing present, it's a trick. Other than that, the detailed method we have talked about. So if you are not finding the trick suitable anywhere, if you are getting confused with the trick part, you can go with the detailed method, but sometimes it becomes very easy and convenient for us to use any of these tricks and to save our time in the exam. Clear? I hope that's clear. And if it is, I would like to give you a question right now, and that's how we will be keep on discussing the important concepts in the session. Give me a second. I will give you one important question and you will be applying the concepts I have discussed here in the question, and I hope it's gonna be helpful. Okay guys, but till that point of time, just check it out if in case you are gonna find like something is not clear to you or somewhere you are going to have any doubt. We will then be talking about it. Okay, just give me a second. Let me just give you some question based on the concepts I have taken right now. Just a second. Want to give you a good one, good question. So it's gonna be okay, this one. Which of the following cannot be the real part of the analytic function? That's the question. Which of the following cannot be the real part of the analytic function? That's what we have to consider. Okay, analytic function. Let's talk about it. If I'm going to talk about the first one, you just need to say yes or no. Can it be or no? Okay, let me just write all the options together. That way you will be able to check out quickly for all the options. X square y, x square minus y square. Option C is x cube minus 3xy square. At the same time, option D is 3x square y minus y cube. 3x square y minus y cube. Just check it out quickly and let me know which one cannot be there. real part of the analytic function? I'm waiting for your reply in the comments. If you will not be getting it, then I will be discussing it too. But if you will get it, then that's great. Just check it out. No. So one, the Cauchy-Riemann equations are the necessary ones for checking out the analytic function. But once you get to know the function is analytic, now the real and imaginary parts will be satisfying the Laplace equation, means they will be the harmonic function. And together we call them the conjugate harmonic functions. Conjugate harmonic functions. Now just check it out, guys, and give me the answer in the comment section, whatever is correct according to you. Mention it, mention it, mention it. On Friday at 4 o'clock also we will be having the mathematical physics session. Okay, Friday at 4 o'clock. So in that session I'll be continuing the discussion about more concepts of mathematical physics. If anybody wants to join that session too, they can. And that will be here on Unacademy Live CSR UGC Net, which is Unacademy's live YouTube channel. Check, 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 and let me know what is the right answer. Look at this. Whichever is not going to satisfy the Laplace equation, that's something cannot be the real part. Okay? Check it out and let me know which one cannot be. Quickly. Let me know which one cannot be. It is expected, I think everybody will be able to do it, because you all know about the formula and the conditions. Go for it, go for it. Guys, as you are gonna get the answer, mention it. Okay, let me just check out the option A here on the screen. So that is x square y. Delta 2 upon delta x square for x square y plus delta 2 upon delta y square x square y. Am I getting it equal to 0? This is gonna be 2x and 2y plus 0. This is just simply 2y not equal to 0. It cannot be the real part because it's not satisfying the Laplace equation, or it's not the harmonic function, hence it cannot be. Let's check this one. It will give us 2 minus 2, which is 0. Correct? For the Laplace equation, it will give you this condition now. At the same time, if I will be checking out the third one, what it will give us? Let's see. It's gonna give us 3x square, okay, for the first time derivative, and then it will give us just simply 3 to the 6x. At the same time here, it will give us 6x. That's 0, okay, difference of both. Here, it will give us a 6y and it will give us 6y with a negative sign. It's 0. This is how you can see all other are satisfying the Laplace equation or the harmonic function condition. Hence, they are the possible real part of the analytic function, but all others are, while option A is not satisfying that condition and it cannot be. So, that's the answer. Now, we will be continuing the discussion in our Friday 4 o'clock session here on Unacademy Live CSR UGC Net. If you want to know about more important points and you want to solve more and more questions, then you can join that session too, guys. And let's keep it this much right now in the session. Also keep on doing the revision of all these sessions. They will be helping you a lot to do the best preparation for the upcoming exam. Even on Unacademy, many new courses are going on right now by the top educators. So if you want to join and attend the sessions of all those well-structured and well-planned courses by the top educators, then you can take the Unacademy Plus or the Iconic subscription. As you can see the details about the Plus and the Iconic subscription here on the screen. If you will be taking the Plus subscription, you will get these benefits. If you will be taking the Iconic subscription, you will be getting these benefits. And by using and by applying the referral code, which is Anjali A Live, as mentioned here on the screen, you will be able to get the 10% discount in the total subscription amount. Mohit, we have covered the metrics topic, almost every important point from the metrics topic. Other than that, we have covered the complex analysis part, okay, like some of the points related to that. And from both the topics, we have also taken the questions. I think even somebody who is going to learn these topics for the first time, for them, this is going to be enough reason behind it. They also need to do the revision and they need to check out the related questions more and more. So if I will just give you everything together, then it may be difficult for somebody who is going to be new to the preparation and learning for these topics for the first time. We also need to take care of everyone now. So I hope you can understand that. So Sovan, let me just check out your comment. Both Cauchy Riemann. Okay, to check function is harmonic or not, we have to use Laplace equation. Correct, so Sovan? Oh, that's great, Suraj. So Sovan, that's correct, and that's what we have checked. This is what we were doing. Delta 2 upon delta x square of this option, delta 2 upon delta y square of this option, and that's equal to 0. If it is equal to 0, it's satisfying the Laplace equation. If no, then it is not. Done? Thank you so much everyone for joining this session. And one more thing, whenever you are going to take either the plus or the iconic subscription, as in upcoming days, many new courses by the top educators will also be starting on Unacademy, and many courses are going on right now. So to join the sessions of these well-structured and well-planned courses by the top educators, you can take the plus or the iconic subscription. Okay, Unacademy plus or Unacademy iconic subscription. And whenever you are going to proceed further to take the subscription, you can use and apply the referral code that's Anjali Live as mentioned here on the screen. And by using and by applying the referral code, you will be getting the 10% discount in the total subscription amount. Thank you so much everyone for joining this session. I hope each and everything, whatever we have discussed in the session, will be clear to all of you. Thank you everyone.